Right now, at this very second, an invisible tempest is crashing down upon us without a sound, without a trace we can easily feel. The sky is raining ghosts. These are not droplets of water or familiar beams of sunlight, but subatomic fragments moving at unimaginable velocities. They pierce the quiet of our atmosphere, carrying whispers of the most violent and cataclysmic events in the known universe. We live our lives entirely unaware of this relentless bombardment, yet it connects our small blue world to the deepest, darkest reaches of space. This silent deluge is composed of cosmic rays. Despite the historical name, they are not rays of light, but physical pieces of matter, mostly protons or atomic nuclei, stripped of their electrons and hurled across the void. While the vast majority possess moderate energy, a rare few arrive with a staggering, almost incomprehensible force. These are the ultra-high energy cosmic rays, anomalous messengers that defy our understanding of how matter can be propelled. They hit hard, carrying more kinetic energy in a single microscopic speck than a fiercely struck baseball. To grasp the sheer power of these mysterious sources, we must look at our own attempts to manipulate matter. Deep underground human ingenuity has constructed massive particle accelerators, rings of superconducting magnets designed to push protons to near the speed of light. Yet, the most advanced machines we have ever built pale in comparison to the natural engines of the cosmos. The universe accelerates particles to energies tens of millions of times greater than anything achievable on Earth, challenging the very limits of known physics. In 1991, an instrument in the Utah desert captured the signature of a single, impossibly energetic particle striking the night sky. Astrophysicists dubbed it the "Oh my God" particle. It was a single proton traveling so close to the absolute speed limit of the universe that if it raced a photon of light across a distance of 1 light-year, the photon would win by mere fractions of a millimeter. The existence of such a particle immediately sparked a profound question regarding what cosmic monster could possibly throw a piece of matter with such staggering violence. Tracing the path of these projectiles backward is an exercise in immense frustration. The universe is not an empty void, but a tangled web of invisible forces. As these charged particles traverse the immense gulfs between galaxies, they are constantly pulled and deflected by sprawling magnetic fields. By the time they reach us, their trajectories have been twisted and bent, erasing the direct line of sight to their origins. They arrive as riddles, stripped of their return addresses, leaving us to hunt for the celestial engines capable of such extreme acceleration. Our search for these engines begins with the explosive deaths of giant stars. When a massive star exhausts its nuclear fuel, it collapses under its own gravity and rebounds in a cataclysmic re,
Yes. Line.
The expanding shock wave from this blast plows into the surrounding interstellar gas, creating a chaotic, highly magnetized environment. Here, particles become trapped, bouncing back and forth across the shock front. With each crossing, they steal a fraction of the explosion's kinetic energy, accelerating faster and faster before finally escaping into the void. Supernovae are spectacular, but their shock waves have a theoretical speed limit. They can easily account for the constant drizzle of lower energy cosmic rays that bathe our galaxy. However, mathematically, a supernova simply cannot hit hard enough to forge the ultra-high energy variants. The stellar debris field is not large enough, and the magnetic fields are not strong enough to hold a particle long enough to reach such extreme velocities. The true sources of the most energetic particles must be something far larger and infinitely more terrifying. This realization forces our gaze outward, beyond the familiar spiral arms of the Milky Way, into the deep intergalactic expanse. If dying stars cannot produce these ultra-high energy particles, we must look to the grandest and most destructive structures in the cosmos. We are drawn to the hearts of distant, ancient galaxies, where gravity reigns supreme and matter is subjected to forces so extreme they warp the very fabric of space-time itself. At the center of nearly every large galaxy lies a supermassive black hole, a gravitational abyss millions or even billions of times the mass of our sun. When these titans actively gorge on surrounding gas and dust, they ignite into active galactic nuclei. An active galactic nucleus is a maelstrom of searing heat and crushing pressure. As matter spirals inward toward the event horizon, intense friction and magnetic tension heat the accretion disk to millions of degrees, creating an environment ripe for extreme particle acceleration. But the true accelerators are likely not the disks themselves, but the colossal jets of plasma that erupt from the black hole's poles, powered by the rotation of the black hole and tightly wound magnetic fields. These jets blast outward at relativistic speeds, piercing through the host galaxy and extending for hundreds of thousands of light years into deep space. The shock waves within these titanic beams act as the ultimate cosmic slingshots, capable of propelling protons to the extreme, ultra-high energies we occasionally detect raining down upon our world. Yet active galactic nuclei are not the only suspects in this cosmic mystery. When entire galaxies collide, the resulting gravitational chaos can spark massive bursts of star formation and drive incredibly powerful galactic winds. These merging galaxies create vast turbulent regions where magnetic fields twist and snap, potentially serving as vast, slow-burning accelerators. Additionally, some astrophysicists theorize that rapidly spinning, highly magnetized neutron stars could whip particles to extreme speeds in the chaotic aftermath of a stellar collapse. A profound paradox shadows the journey of these ultra-high energy particles. According to the laws of physics, the universe is not entirely transparent to such extreme travelers. Space is permeated by the cosmic microwave background, the fading afterglow of the Big Bang. To a proton traveling at near light speed, this low-energy radiation appears as a dense, blinding wall of gamma rays. Collisions with this ancient light should drain the cosmic ray's energy over vast distances, a theoretical threshold known as the GZK limit. The GZK limit dictates that any ultra-high energy cosmic ray striking Earth must have originated relatively nearby in cosmic terms, likely within roughly 160 million light years. If they came from deeper in the universe, the afterglow of creation would have sapped their extreme power. This narrows our search radius, yet the mystery only deepens. Within this local cosmic neighborhood, there are very few active galactic nuclei or merging galaxies powerful enough to be the culprits. The sources remain stubbornly hidden, shrouded in the invisible magnetic fog of the local universe. After millions of years wandering the intergalactic void, a surviving particle finally intercepts the path of a small rocky planet orbiting a yellow dwarf star. It plunges into Earth's atmosphere, but it never reaches the ground intact. At an altitude of roughly 20 miles, the incoming proton collides violently with a nitrogen or oxygen nucleus in the thin upper air. This catastrophic impact shatters both the cosmic ray and the atmospheric atom, instantly converting the immense kinetic energy into a shower of new secondary particles. This initial collision triggers a sprawling, cascading chain reaction. The newly minted particles streak downward, colliding with more air molecules, creating even more particles in a rapidly multiplying avalanche. What began as a single microscopic projectile blossoms into an extensive air shower, a disk of billions of subatomic fragments spreading out over miles of the sky. By the time this invisible debris reaches the surface, it is a vast simultaneous downpour of secondary radiation. To catch these ephemeral showers, scientists have transformed vast tracts of the Earth into sprawling observatories. In the high plains of South America and the deserts of North America, arrays of water tanks and specialized telescopes sit in silent vigil. They do not look for the original cosmic ray, but wait for the faint flashes of light and the synchronized triggering of detectors spread across hundreds of square miles. It is a massive net cast out to capture the footprint of a ghost, allowing us to reconstruct the energy and trajectory of the original particle. Naturally, one might wonder if this relentless high-energy bombardment can harm Earth or its inhabitants. For those of us on the surface, the thick blanket of our atmosphere and the planet's magnetic field act as an incredibly effective shield, absorbing the brunt of the impact. The secondary particles that reach the ground pass through us harmlessly every second. However, for astronauts in deep space or sensitive electronics on high-altitude satellites, these particles are a serious hazard, capable of flipping digital bits or damaging cellular structures if left unshielded. Every flash captured by our detectors is a tiny, vital piece of a much larger puzzle. These ultra-high energy cosmic rays are the only direct samples we receive of matter from outside our solar system, accelerated in conditions we could never hope to replicate. They are extreme physical anomalies that test the boundaries of relativity, particle physics, and cosmology. By studying them, we are not just cataloging space debris, we are probing the fundamental laws that govern the mechanics of reality itself. The study of these particles transforms our perception of the night sky. It is not a serene, silent canopy, but a dynamic, roaring theater of extreme violence and unimaginable power. The invisible rain that falls upon us is a constant reminder that our tranquil world is deeply embedded in a wild and chaotic cosmos. We are intimately connected to the explosive deaths of stars and the feeding frenzies of supermassive black holes, bound together by the microscopic messengers that traverse the dark. As we continue to stare into the abyss, waiting for the next impossibly energetic visitor to light up our atmosphere, the profound mystery endures. The universe is speaking to us in a language of shattered atoms and relativistic speed. Each cosmic ray is a testament to the sheer untamed power of nature, a silent spark bridging the unfathomable distances. In our quest to uncover their mysterious sources, we are slowly unlocking the ultimate secrets held within the cosmic vault, forever chasing the invisible ghosts of a magnificent, violent universe